Okay, so we're going to close out this lesson with an example. And this example is going to go through a lot of different aspects of what we would be asked to do in analyzing motion. Okay, so we have the position of a particle given by this position function. T is measured in seconds and position in meters. So the first thing it's asking us to do is find the velocity, which means we have to take the derivative of the position. So that'll be 3t squared minus 12t plus 9. And then in the second part, it's asking us when the particle is at rest. So we mentioned this in the last video, the particle will be at rest when the velocity is 0. So I'm going to need to solve this equation. It will probably be easiest for me to do if I factor. And so I get three, pretty sure that's two, two different answers. So it's at rest at 1 second and at 3 seconds. And then the question is asking me, when is the particle moving forward or in the positive direction? So this is where that sign chart for velocity is going to come in. I'm going to label it here. And you know what, actually, it doesn't really make much sense for me to have it go on forever in the negative direction because, so I've got my numbers all in the wrong place, because time starts at 0, right? So then I have that at 1 second and at 3 seconds, the velocity is 0. So remember, to make a sign chart, I'm going to put the value of this function above, and this would be the t values below. And so now what we need to do is pick a number in each one of these intervals, plug it into the velocity function. Probably here is going to be easiest because all you care about is the output positive or negative? So for example, if I put, I'm going to pick 1/2. It's going to be kind of a pain in the butt to plug it in here. But if I plug it in right here, I have, that's going to be negative. That's going to be negative. So I have a positive times a negative, that's a positive. That's all I care about because that means that all of the t values on that interval will have a positive velocity. So think smarter, not harder. All right, I'm going to plug in something between 1 and 3. 2 sounds good. That would be a negative and a positive times a positive. So that would be negative. So all of the t values between 1 and 3, the velocity will be negative. And last but not least, I'll plug in something here like a 4, positive, positive. So my velocity will be positive there. So this sign chart is going to come in helpful to answer any questions. I mean, this particular one asked us, when is it moving forward? And so I can report that it's doing so on 0 to 1 and on 3 to infinity. These are the 2 time intervals that the particle is moving forward or has a positive velocity, right? But I could have, the question could have asked me when it was moving in the negative direction, and this sign chart will still answer that same question. I am going to leave a space underneath this sign chart because eventually they're going to ask me about speeding up and slowing down. And remember, we said we need to compare velocity and acceleration. So what I usually do is leave some space underneath my velocity sign chart for my eventual acceleration sign chart. So just go ahead and leave that space. We'll get to it in a minute. First, we need to answer part D, which is asking us, what is it asking us? Oh, draw a diagram. Okay, perfect. So if we went back to the original pictures, these are motion diagrams. It is not a position versus time chart graph. Instead, it's a diagram that just shows with arrows the motion of the particle. So if it stops and changes direction, we indicate it like this by drawing the arrows above each other. Of course, really the particle is just going back and forth like this, but we can't draw those arrows directly on top of each other. So we're going to use that sign chart for velocity. And we're going to figure that we need to start at obviously t equals 0, and we'll draw an arrow to the right. But we need to figure out what's the position where it starts and what's the position where it stops going right. And then we'll draw an arrow to the left, and what's the position when it stops turning left and turns right again. So the first thing we're going to need to do is find S of 0, S of 1, and S of 3, so that we can apply those positions to our diagram. So if you plug them in, which I already did. Oh no, I already didn't. Oh yes, I did. S of 1 was 0. S of 0 was 0. S of 1 I got 4, and S of 3 is 0. So to do our motion diagram, we combine those positions with our velocity, as I just said. So we're going to start at position 0, then we're going to move right to position 4, then we're going to move left back to position 0, and then it will continue to move right. So one way that you can do this is like basically draw like a number line that all these arrows are going to go over. So these are my two positions. And then I'm just going to draw my arrow. I start here at t equals 0. And I end at 4 at t equals 1. And then it goes left back over here to 0. And that happens at t equals 3. And from then on, it just goes in the positive direction. So you can see that we've diagrammed this motion, then back, then forever like this. Okay. Some people do connect them, so they sort of draw it like this. And that's fine if you want to do that. As long as we're all realizing that that motion is not really that it's climbing in any way, shape, or form. It's just going back and forth. But each diagram should have the direction of motion. So there's an arrow, right? It should have the position at these times and the time that it reaches there. So that is what a motion diagram contains. It is not a position versus time graph. It is not a two-dimensional XY graph. Okay, and so then on part E, the question is asking me, find the total distance traveled by the particle in the first 5 seconds. Well, we're most of the way there, because we can just look at our picture and see that it traveled 4 in the first second, and then 4 again in the next 2 seconds. So I really just need to figure out where is it at t equals 5 along this line. So I know that on 0 to 1, it travels 4 meters. On 1 to 3, it traveled an additional 4 meters. And then on 3 to 5, it travels how far? So I'm going to need a quick S of 5. I plugged that in and I got 20. So clearly that's a little off my scale, but if it started at 3, here at 0, and then went to 20, then it traveled 20 meters during that time. So that is a total distance traveled of 28 meters. Okay, and last but not least, for part F, we've arrived at the question for when is the particle speeding up and slowing down? So we need to analyze velocity and acceleration together. So let me start down here. I'm going to go up to that sign chart in just a second. So first I need to find the acceleration. So I'm going to take the derivative of the position. And then to create my sign chart, I need to know when is this 0. So that will be at 2. So I'm going to come back up here to my acceleration. And I want to line these up. So I'm going to put my 2 where it would fall on in the same location in terms of the velocity sign chart. And now I need to fill in the positives and the negatives for acceleration. So when I look at something that would be less than 2, like 1, I would get a negative. And if I looked at something bigger than 2, like a 3, I would get a positive. So I'm going to fill those in here, negative and positive. And so one way to help you see this, I feel that's really helpful, is kind of just drawing these vertical lines at the places where both velocity and acceleration have their zeros. Because now you have this region and you can compare their signs. They're opposite signs. So that means it's slowing down here. Here's another region in between. They've got the same sign, so it's speeding up here. One more region, opposite signs, slowing down, and finally speeding up. So I'm gonna fill in my answer to F right here so I can view my comparing charts together. So it's slowing down, what we say, on 0 to 1 and 2 to 3. And it is speeding up 1 to 2 and 3 to infinity. Okay. So that completes kind of a full motion analysis, just given a position function.